Levi Lambert,
I'm Peter Molitor.
and this is our guest, Renee Michelle. Our concept is based on a hands-on method of dissection, which combines all the positive effects of physical dissection with the positive effects of digital dissection, because each of them have like their own benefits. So we want the benefits of regular dissection, which are the hands-on experience that it has that some people say digital dissection don't, but digital dissection still being cheaper is going to be a better option, and that it's safer, there's no formaldehyde, there's no real risk with it like there would be with traditional dissection.
So our hypothesis is we're trying to capture the benefits of both traditional dissection, which you get your specimen and you cut it open and look inside, and digital dissection, which is like the frog in the computer that you might have had a lab for in the past. And we want something in the middle that captures both of the benefits. So what we're trying to do is, through new technologies, we are hoping to get something that gets right in the middle and without any disadvantages adds advantages to normal dissection.
Our methodology, we haven't completely decided which route we're going to take. Our main option is probably going to be through augmented reality, in which the instructor and all of the students would all be viewing the same specimen, but it would be properly labeled with guided annotations, which you could also turn off in order to create a testing environment for the student, in which they will basically reconstruct the specimen.
All right, so our first idea for how we would do this is we go in steps from 3D modeling to virtual reality to a hologram. And we start out with 3D printing, so we can 3D print a lab animal so that students can work with it, and there's none of the formaldehyde or just the blood and other fluids that need to be cleaned up that come with a normal animal. And 3D printing is sort of our first approach. It's here. We have 3D printers at the school. More and more schools are getting them. So schools could do that themselves now. And our next idea for it is using virtual reality. Things like the Oculus Rift are coming out now, and they're meant to be in homes everywhere. So if we get them in schools, students can put it on, they can see the animal, they can interact with it using their hands, and tools that don't physically have to be there, so nothing sharp, but they can use tools to interact with the animal, and there's not danger of cutting yourself, being exposed to chemicals. And our third and final method of dissecting is using an interactable hologram, which that technology is being worked on. It's not complete yet, but in the future, having a hologram that you can just put on the desk and you can dissect is the simplest and most efficient way a student can learn.
So the most likely people to use our project would be any institution that wants to do dissections and wants a more effective method for doing it. The other benefits of it is that they would have one hardware module that they would be able to basically download new organisms that they want to dissect. The next likely would be augmented reality technology pioneers. As Peter was saying, any company is going to want the program to use and make it compatible with their devices. And the next, but least likely people to use it would be animal rights organizations.
All right, and talking about the virtual reality companies some more, because that's our primary focus. There's the main two companies right now are Oculus Rift, which is owned by Facebook, and Project Morpheus, which is Sony. Both of these companies have been interested in education before, and as an incentive to help educators. It's good publicity for them. If you help a school, people are going to like you for that. So they'll have a reason to make it cheaper and make it more available in schools.
Awesome. Okay, so questions. I feel like I'm living the Tomorrowland. You know? Yeah. So, questions?
For the 3D printer idea, how much did you expect that to cost? Is it expensive?
It's not, basically it's not as expensive as getting an actual lab animal. I'm not completely sure of the price, but it's cheaper.
And if you have your
And
own
easier.
extruder, then you can produce your own film then anyways, so.
It actually would be cheaper in the long run. It's like having a solar energy. You know, the first investment maybe because each unit is expensive, right? But if you think about every semester, we have to buy, you know, fetal pigs and frogs and all of that and order them. And then the chemicals for preserving, that's a lot of money, actually. And that's why a lot of schools, you know, are starting to not anymore do dissections because of that reason. And then, of course, the health part of that, which is Michelle here will probably really attest on, you know, exposure to formaldehyde and all the things that they were talking about. That's pretty, really good idea to kind of replace. They're doing that already in the nursing. Yeah, in the nursing departments, they have models. Okay, they're not 3D. They're really molded models, you know, and they are expensive. But it's better, you know, because they have a good than buying a cadaver. Because they used to really buy cadavers, you know, and there's one is it's not always there, you know, because not a lot of people sell their cadavers. Only those that were not claimed, you know, are being sold. And so it's not all the time you have those. So that really is a very good idea. It can be realized, right?
Right.
The questions?
Also, in addition to that, I haven't checked, but I assume it's possible to take the cut-up dissection animals that were 3D printed and reuse it, like melt it
Right.
down.
Extrusion.
Yeah.
Go ahead.
Have you guys heard of the amusement park, the Rift, which is completely virtual reality? With the technology we're using, we have a pressure-sensitive chest plate and hand and gloves, so you can actually feel if you're holding something in the virtual reality, or if you get hit by something in virtual reality. Would you be trying to implement a similar technology in order to be actually holding a scalpel during the virtual dissection?
Yeah, the idea would be so that your hands can interact with it,
Yeah, I can feel
and
it.
the pressure sensors would be a great addition to that.
That is a great idea. Yeah. You feel like it's real. Yeah. Not just plasma.
Any other questions? All right.
One last
Question?
Oh, sorry.
Question?
One of the things that Dr. Rainey, we talked about the cost of just the setup and the fetal pigs and all of those things, but what most people don't think about is the cost of disposing it. Disposing of it is also another issue, and there's also a cost of exposure. So everybody's different. You might have someone who may only take a very small amount of chemicals that maybe I would be okay with, but the other person may not be okay with. So taking into consideration, cost is actually more. You have to take into consideration the hazardous waste portion of it, and not to mention the permitting fees that goes along with the disposal of hazardous waste, or in this case, biological waste.
Right. Thank you.